In the dawn of human curiosity, before there were laboratories or equations, before science had a name, the universe was a mystery wrapped in light, sound, and motion. The wind carried secrets, the thunder spoke in tones of power, and the spark of lightning seemed to be the hand of the divine touching the world. Long before humanity understood what a force was, it felt the tremors of unseen powers shaping existence. The ancients stood beneath the vastness of the sky and watched lightning strike, trees ignite, and the heavens roar, wondering what invisible strength commanded such chaos. These were the earliest encounters with what we now call the forces of nature, electricity, magnetism, and light, and they inspired both awe and fear. To the people of early civilizations, these phenomena were not natural, but supernatural. They were messages from gods, signs of favor or fury, and expressions of a universe beyond comprehension. In ancient Egypt, priests studied the heavens and the storms, associating lightning with the gods who ruled the skies. In Greece, philosophers began to question these phenomena not as divine whims but as natural processes. Tales of Zeus wielding thunderbolts and controlling storms captured the imagination, yet behind those myths lay a flicker of human wonder. What if there was a pattern, a reason, a hidden order behind the spectacle of the storm? Thales of Miletus, one of the earliest philosophers, once rubbed amber with fur and watched it attract bits of straw. To him, this was a curiosity. To us, it was one of the first recorded observations of static electricity. Without knowing it, he had touched the edge of an invisible world, the realm of electric charge. At the same time, the magnetic stones of magnesia drew iron without contact, behaving as if alive. People called them lodestones, and sailors would later use them to guide their journeys across unknown seas. These mysterious rocks hinted at forces that could act across empty space, invisible, silent, and yet undeniably powerful. Humanity's fascination with such wonders grew as it began to suspect that the visible world was only a surface beneath which deeper laws operated. The journey to understanding these hidden powers would span centuries, guided by thinkers who dared to see nature not as a collection of miracles, but as a unified system governed by rules waiting to be discovered. Centuries later, during the great age of philosophy in Greece, thinkers like Aristotle and Plato pondered the nature of motion, attraction, and change. They lacked the tools of experiment, but their curiosity laid the foundation for the scientific spirit. The Greeks believed the universe was composed of elements, earth, air, fire, and water, governed by harmony and proportion. This search for harmony would echo through the ages, driving scientists to find unity among the forces they observed. The magnetic stone, the flicker of static charge, the glow of sunlight, all seemed separate manifestations of nature's mystery. Yet somewhere in the depths of human imagination, the idea of connection began to take root. In China, early scholars experimented with magnetism centuries before Europe would even record it. The south-pointing spoon, an early compass, demonstrated that magnetism could guide direction, hinting that the Earth itself might be a giant magnet. Meanwhile, in the temples of Alexandria and the academies of Athens, early inventors created devices that used static electricity to move light objects or make sparks. These curiosities were amusements, not yet science, but each spark was a symbol, proof that unseen energies could be touched, harnessed, and maybe someday understood. The medieval era dimmed the flame of scientific progress for a time, as mysticism and superstition replaced inquiry. The natural world was seen through the lens of faith rather than reason, and invisible forces were once again attributed to divine intervention or magic. Yet even then, the questions never vanished. Alchemists and natural philosophers continued to experiment, guided by both wonder and ambition. They sought to uncover hidden properties in matter, believing that understanding nature's secrets could reveal the essence of creation itself. Though many of their pursuits were misguided, their persistence kept alive the spark of investigation that would later ignite into the scientific revolution. When the Renaissance arrived, the world awakened to a new kind of vision, one that valued observation, measurement, and the relentless pursuit of truth. Figures like Galileo and Kepler transformed philosophy into science, turning curiosity into method. The heavens, once thought immutable, were revealed as governed by mathematical laws. Isaac Newton's Principia Mathematica united the motion of the planets and the fall of an apple under one universal principle: gravity. For the first time, humanity realized that the same force binding the moon to the earth guided every motion in the cosmos. It was a revelation that transformed our understanding of nature's unity. But even as Newton explained gravity, other invisible forces remained elusive. What was the nature of electricity and magnetism? Could they too be governed by a single law? As Europe entered the 18th century, a new age of experimentation began. Scientists like Benjamin Franklin, Luigi Galvani, and Alessandro Volta explored the strange phenomena of sparks and shocks. Franklin's famous kite experiment revealed that lightning was not a weapon of gods, but a form of electricity, the same mysterious energy produced by rubbing amber centuries earlier. This was a turning point in human understanding. The heavens were no longer divine mysteries, but laboratories of nature's power. Electricity had been brought down from the clouds and into human hands. Volta's invention of the electric battery transformed that power into something controllable and measurable, marking the birth of modern electrical science. Yet while electricity could now be produced and stored, its nature remained uncertain. Magnetism, too, was still a riddle. Compasses pointed north, magnets attracted metals, but no one knew why. Then, in the early 19th century, a quiet revolution began in the laboratories of Europe. Hans Christian Ørsted, a Danish physicist, made a simple but world-changing observation. When an electric current passed through a wire, a nearby compass needle moved. Electricity and magnetism were not separate after all, they were deeply connected. This discovery shattered centuries of assumptions and opened a new era of understanding. The invisible forces that had puzzled humanity since ancient times were beginning to reveal their unity. Soon after, André Marie Ampère and Michael Faraday on this discovery, uncovering the principles that governed electromagnetic interactions. Faraday, in particular, brought a poetic sensitivity to his work. He saw fields, invisible lines of force stretching through space, connecting particles and charges in a vast, dynamic web. His experiments revealed that magnetism could produce electricity, and electricity could produce magnetism. These were not independent forces but two faces of one greater power. Faraday's imagination went beyond what instruments could measure. He believed that light itself might be related to electromagnetism, a bold idea that would later find its proof in the work of a Scottish genius named James Clerk Maxwell. But before Maxwell entered the scene, humanity's long quest to understand nature's hidden forces had already transformed how it saw the universe. From myths of gods hurling thunderbolts to experiments capturing electric sparks, the journey had been one of evolution, from wonder to comprehension, from superstition to science. Each discovery had peeled back a layer of mystery, revealing that the universe operated according to consistent, mathematical laws. Yet, the deeper scientists looked, the more they realized how interconnected those laws might be. The concept of unity, the dream of one framework to describe all forces, became the guiding light of physics. Still, the road to understanding was far from complete, even as electricity and magnetism began to merge into a single theory. The connection to light remained speculative. What was light? Was it a particle, as Newton claimed, or a wave, as Huygens believed? Could it be something entirely new, a bridge between the mechanical and the electromagnetic? These questions set the stage for one of the greatest breakthroughs in the history of science. But long before that revelation, humanity's relationship with the invisible had already changed forever. The natural world was no longer a realm of mysteries beyond comprehension. It had become a language to be decoded. From ancient temples to modern laboratories, the quest to understand invisible forces reflects something timeless in the human spirit: the refusal to accept ignorance as destiny. Every civilization, from the builders of the pyramids to the architects of telescopes, has looked beyond what is seen, sensing that the true workings of the universe lie hidden beneath the surface. This search is not only scientific, it is philosophical, even spiritual. To understand the invisible is to seek harmony with the cosmos, to find meaning in the patterns that govern existence. As time moved forward, each discovery deepened humanity's relationship with these unseen forces. Electricity illuminated cities and powered machines. Magnetism guided explorers and enabled communication across vast distances. Light became both a tool and a symbol, the embodiment of knowledge itself. Yet the question remained, could there be a single principle connecting them all? Nature seemed to whisper that unity was possible, that the forces once thought distinct were threads of one grand design. By the mid-19th century, the stage was set for the ultimate revelation. The separate discoveries of the past had built a foundation of knowledge, but it would take one extraordinary mind to see the full picture, to unite electricity, magnetism, and light into a single framework that described their shared essence. The centuries of curiosity, observation, and imagination had led to this threshold. Humanity had come far from its earliest fears of lightning and magnetism, yet it stood on the brink of a new understanding, one that would redefine the limits of science and reveal the elegant simplicity of the universe's design. This was the journey of the first keynote, a voyage through time, thought, and wonder. It is a story of how human beings evolved from witnesses of nature's spectacle to interpreters of its laws, from the first spark that startled the ancients to the experiments that electrified the modern world. The thread of curiosity never broke, and through that thread humanity discovered that what seems invisible is never truly separate. It is part of a larger, unified reality, waiting for someone to see its connection. The dawn of understanding was approaching, and soon, one man would bring light to the invisible, weaving together the forces of nature into one harmonious vision of the universe. As humanity entered the modern age, the whispers of the invisible forces grew louder. The world was changing fast, machines began to roar, cities glowed with new light, and the hum of progress echoed through the air. Yet behind all this motion lay mysteries still unsolved. Electricity could shock power and illuminate, but what truly was it? Magnetism could pull iron and point compasses, but what drove its strength? Scientists and thinkers knew they were standing on the edge of something vast, something that could unite the phenomena of the natural world under a single, elegant principle. The centuries-long story of wonder was now transforming into one of revelation. The early 19th century became the crucible of experimentation. In laboratories lit by candles and driven by imagination, pioneers like Michael Faraday and Andrei Marie-Ampere were uncovering relationships that defied old assumptions. Faraday's vision of lines of force was revolutionary. He imagined space itself as alive with invisible threads connecting particles, where every movement of electricity created a magnetic field, and every magnetic field could give birth to electricity. This vision was not just scientific, it was poetic. Faraday, who had little formal education, relied on intuition and faith in the unity of nature. In his mind, the universe was woven together by unseen patterns, and his experiments with coils, magnets, and currents revealed those patterns one spark at a time. Faraday's discovery of electromagnetic induction was a breakthrough that changed the world forever. When he moved a magnet through a coil of wire, he produced an electric current. That single act, the transformation of motion into electricity, became the foundation of modern power generation. Every electric motor and generator today owes its existence to that moment of insight. Yet Faraday's work carried deeper implications. It suggested that the forces of electricity and magnetism were not just linked but were aspects of the same underlying phenomenon. Still, Faraday lacked the mathematics to express his vision in precise terms. He saw the unity, but it remained a picture in his mind, a vision waiting for words that could capture its full meaning. Then, in the mid-19th century, a young Scottish physicist named James Clerk Maxwell stepped forward. Born in 1831, Maxwell was a man of extraordinary intellect and imagination. He had grown up surrounded by the hills and skies of Scotland, where nature spoke to him in patterns and rhythms. From a young age, he was fascinated by geometry, light, and the idea that the world could be described through elegant mathematical relationships. When he encountered Faraday's experimental work, he saw more than just laboratory results. He saw a cosmic language written in the form of fields and waves. Maxwell translated Faraday's intuitive ideas into mathematical equations. In doing so, he created one of the greatest unifications in the history of science. His equations described how electric and magnetic fields are generated and altered by each other and by charges and currents. They revealed that a changing electric field produces a magnetic field, and a changing magnetic field produces an electric field. From these intertwined relationships emerged something astonishing: waves of electromagnetic energy that could travel through empty space. When Maxwell calculated the speed of these waves, he discovered it was exactly the speed of light. The conclusion was inescapable: light itself was an electromagnetic wave, a vibration in the invisible field that fills the universe. For centuries, light had been one of nature's deepest mysteries. Was it composed of particles or waves? Did it travel through a medium called the ether? Maxwell's work provided the answer. Light, radio waves, X-rays, all were manifestations of the same fundamental phenomenon. In one stroke, Maxwell had unified electricity, magnetism, and light into a single framework. The invisible forces that humans had once feared and worshipped were now revealed as different expressions of one universal field. This was the fulfillment of humanity's oldest dream, the discovery of unity behind diversity, order beneath chaos. The impact of Maxwell's discovery rippled far beyond the world of physics. His equations were more than scientific tools; they were a philosophical revelation. They suggested that the universe is bound together by continuous, interwoven fields of energy. Nothing acts alone; every motion, every current, every spark interacts with the vast electromagnetic fabric that surrounds us all. This realization reshaped humanity's understanding of the cosmos. The universe was no longer a collection of isolated objects, but a connected whole, alive with invisible relationships. The late 19th century witnessed the transformation of Maxwell's theory from abstract mathematics into practical power. Scientists and inventors such as Heinrich Hertz, Nikola Tesla, and Guglielmo Marconi turned the invisible waves Maxwell had predicted into tangible reality. Hertz proved the existence of electromagnetic waves experimentally, generating and detecting radio signals across a room. Tesla harnessed alternating current, bringing electricity into homes and cities. Marconi sent messages through the air, inaugurating the age of wireless communication. Each of these achievements traced its lineage back to Maxwell's unification of the invisible. The once mythical forces that ancient humans attributed to gods now obeyed the equations of a man who had seen the universe as one. Maxwell's unification was not merely about connecting electricity, magnetism, and light; it also set the pattern for all later scientific revolutions. His success inspired future generations to seek further unity among the fundamental forces. When Albert Einstein studied Maxwell's work, he recognized in it the seed of his own theory of relativity. Maxwell's equations showed that the speed of light was constant, no matter the observer's motion, a clue that led Einstein to reformulate our understanding of space and time. In this sense, Maxwell not only unified the invisible forces of nature, he also prepared the ground for a new vision of the universe where energy, matter, and spacetime were interwoven in a deeper unity still. But to appreciate the magnitude of Maxwell's contribution, one must remember where the journey began. Thousands of years earlier, humans trembled before lightning, worshipped magnetic stones, and gazed at the stars without knowing what light truly was. Every era added a new piece to the puzzle, from Thales's amber to Faraday's fields, but it was Maxwell who assembled them into a coherent picture. His four equations, simple yet profound, stand among the greatest intellectual achievements in history. They are to electromagnetism what Newton's laws were to motion, and more. They revealed that what we see and what we cannot see are connected by the same physical reality. The elegance of Maxwell's vision lay in its universality. His equations did not merely explain laboratory experiments, they described the behavior of the entire electromagnetic spectrum, from the longest radio waves to the most energetic gamma rays. They showed that the universe hums with invisible energy, a sea of oscillating fields that bind matter together and carry information across space. Every beam of sunlight, every radio transmission, every flicker of a television screen is an echo of Maxwell's insight. The dance of electric and magnetic fields in harmony. The cultural impact was equally profound. For the first time, humanity could visualize the invisible. Artists, writers, and philosophers of the late 19th and early 20th centuries found inspiration in the idea of unseen fields filling the cosmos. It changed not only science but also how people thought about reality itself. If invisible forces pervaded the world, perhaps the visible was only a small part of a much larger whole. Maxwell's unification thus became both a scientific and a metaphysical milestone, bridging the tangible and the transcendent. As technology advanced, the fruits of Maxwell's work transformed civilization. Electricity powered factories and homes, magnetism enabled motors and generators, and electromagnetic waves carried voices and images across continents. The invisible became the foundation of modern life. Every light that glows, every phone that rings, every satellite that transmits a signal is a living testament to the unity of forces Maxwell revealed. The dream that began with the wonder of lightning and lodestones had become the reality of a connected world. Yet, despite the immense progress, Maxwell's story also reminds us of humility. His equations describe beauty and symmetry, but they also hint at deeper mysteries still unsolved. Later physicists would discover other fundamental forces, the strong and weak nuclear interactions, and begin a new quest for a grand unification. Maxwell's achievement remains a guiding example, a reminder that nature's complexity may always conceal an underlying simplicity. His work encourages every generation to look beyond the visible, to seek the patterns that connect what seems separate, and to trust that the universe, in all its vastness, speaks one coherent language. As the camera of imagination pans across time, one can see the thread of continuity stretching from the ancient philosopher, rubbing amber to the modern scientist, sending signals across galaxies. The journey of understanding the invisible forces is a human story, of curiosity, courage, and creativity. Each generation built upon the last, not merely collecting facts but expanding perception itself. What began as awe became knowledge, and what was once worship became understanding. The unification of the invisible was, in truth, the unification of the human spirit with the cosmos. Maxwell's life ended young. He died at only 48. Yet in his brief years, he accomplished what few ever could. He revealed the architecture of the unseen. His legacy endures not only in science but in every corner of modern existence. The digital age, the communication revolution, the exploration of space, all trace their origins to the moment Maxwell wrote down his four equations and in doing so, unveiled the harmony of the electromagnetic world. His work stands as proof that imagination guided by reason can illuminate the darkest mysteries. Even now, more than a century later, Maxwell's unification remains a cornerstone of physics. It continues to inspire new discoveries in quantum theory, relativity, and cosmology. It reminds us that the universe, though vast and complex, is not chaotic but profoundly ordered. The invisible forces that shape our world are threads in a grand tapestry, a cosmic symphony of energy and motion. When we hold a magnet, flip a switch, or look at the stars, we are witnessing the legacy of that unification, the culmination of a journey that began with wonder and ended with understanding. And yet the story does not truly end. Each revelation opens a new horizon, each equation hints at deeper truths. Maxwell's unification teaches us that knowledge is not a final destination, but an ever-expanding frontier. The same curiosity that led the ancients to marvel at lightning now drives scientists to explore the quantum and the cosmic, seeking a deeper unity still, one that will tie together all forces from gravity to electromagnetism into a single, all-embracing theory. The quest that began in the flicker of a spark continues in the hum of a particle accelerator and the glow of distant galaxies. So, as we reflect on the mysterious beginnings of natural forces and humanity's long quest to understand them, we see a pattern that transcends time. From myth to mathematics, from superstition to science, every step in this journey reflects the same impulse: to make the invisible visible, to find order in the unknown. The story of unifying the forces of nature is not just a chronicle of experiments and equations, it is a testament to the enduring human drive to comprehend the universe, and, in doing so, to find our place within it. When lightning flashes across the sky, when a compass aligns itself to the Earth's magnetic field, when light spills across the horizon at dawn, all these moments are echoes of that unity. They are reminders that beneath the surface of experience lies a vast network of invisible connections, governed by laws so elegant that they border on the poetic. Maxwell's unification revealed that beauty and truth are often one and the same. In the rhythm of his equations, the universe speaks in harmony. From the first spark that startled the ancients to the equations that shaped modern reality, humanity's journey toward understanding the invisible forces of nature is both a scientific odyssey and a spiritual awakening. It is the story of how curiosity became knowledge, how wonder became wisdom, and how one man, guided by imagination and intellect, wove together the invisible threads of the cosmos into a single, luminous design. And as the final echoes of that discovery ripple through time, we are reminded that the universe itself is not silent. It hums with energy, with light, with connection, a timeless chorus of the very forces that once seemed beyond reach. The mystery that began in fear ended in understanding, and the understanding continues to evolve. The invisible is no longer unknown, it is the very essence of what makes the universe alive. Through Maxwell's unifying vision, humanity learned that the forces shaping the stars and the sparks in our hands are one and the same, bound together in the magnificent, invisible fabric of reality. There are rare moments in history when a single mind seems to see farther than all others, when imagination and reason merge to unveil a hidden order in the universe. The 19th century was a time of great discovery. The Industrial Revolution roared, steam and steel reshaped cities, and science itself was evolving from philosophy into a precise language of laws. Yet amid this noise and progress, there was one mystery still unsolved, a puzzle that defied all boundaries: what connected the strange, invisible forces of electricity, magnetism, and light. In that era of transformation, a quiet Scottish boy named James Clerk Maxwell was born in 1831 in the green hills of Edinburgh. To his family, he was a child of curiosity, a boy who would spend hours studying patterns of light through glass, the motion of ripples on water, or the symmetry of flowers. His fascination with geometry began before he could even write. He used colored threads and pieces of paper to explore the shapes hidden within the world. Those around him saw a child lost in wonder, but in truth, Maxwell was developing the same mindset that would later allow him to see unity in nature where others saw separation. As he grew, Maxwell's brilliance became undeniable. He absorbed mathematics as if it were poetry, drawn not only to its precision but to its beauty. While other students solved problems, Maxwell saw patterns, rhythms, and harmonies, the music of the universe expressed in symbols. His teachers often struggled to keep up with his leaps of logic, but they recognized in him a rare gift, a mind that saw the abstract not as cold calculation, but as living truth. In the universities of Edinburgh and Cambridge, Maxwell refined his thinking, surrounded by some of the greatest minds of his generation. The scientific world at that time was still guided by the legacy of Newton, who had united the heavens and the Earth through the law of gravity. Yet even Newton's elegant universe had boundaries. Gravity explained how masses attracted one another, but not how light moved, how magnets pulled, or how electricity flowed. These forces seemed to operate by their own mysterious rules. Scientists like Michael Faraday had discovered that electricity and magnetism could create each other, a revelation that electrified Europe. But the underlying mechanism was unclear. Faraday was a man of experiment rather than mathematics. He saw invisible lines of force filling space, connecting charges and magnets through unseen tension. He drew diagrams of these lines curving through air, wrapping around coils of wire, forming loops of energy. To many of his contemporaries, these sketches seemed mystical, beautiful but vague. Yet to Maxwell, they were a revelation. He saw in Faraday's drawings not confusion, but order waiting to be expressed in the language of mathematics. Maxwell's gift was to translate intuition into logic, vision into equation. He believed that the forces of electricity and magnetism were not separate at all, but two sides of the same phenomenon, and that light itself might be the bridge between them. It was a bold idea, one that required both imagination and courage. At the time, electricity was studied in laboratories with sparks and wires, while light was studied by astronomers and physicists through lenses and prisms. No one imagined they could be related, but Maxwell had begun to see something no one else could: patterns that repeated across both realms, hints of unity hidden beneath complexity. In the 1850s, while still a young man, Maxwell began the work that would change science forever. He immersed himself in Faraday's experimental results, searching for mathematical relationships that could explain them. He saw that a changing electric field could create a magnetic field, and a changing magnetic field could, in turn, create an electric field. This mutual generation meant that once set in motion, such a pair of fields could sustain each other, like waves rippling endlessly through space. This was the birth of a revolutionary concept: electromagnetic waves. Maxwell realized that if these waves could move through space, they must travel at a certain speed. Using known constants for electricity and magnetism, he made a calculation, and what he found left him awestruck. The speed of these waves matched precisely the speed of light itself. It was no coincidence. Light, he concluded, was an electromagnetic wave, a vibration of electric and magnetic fields traveling through the vast emptiness of space. The light that fills our skies, the glow of stars, even the warmth of the sun, all were the same phenomenon as the spark from a wire or the pull of a magnet. This was not just a discovery, it was a unification. Electricity, magnetism, and light, three forces that humanity had studied separately for centuries, were, in fact, one and the same. Nature, Maxwell revealed, was simpler and more elegant than anyone had dared imagine. In that moment, he joined the ranks of Newton and Galileo, those rare thinkers who redefined reality itself. But Maxwell's journey was not without struggle. The world of 19th century science was slow to accept new ideas, especially those expressed in dense mathematics. Many of his peers could not grasp the beauty of his equations, nor the vastness of their implications. Even Faraday, whose intuition inspired Maxwell's work, found the mathematics difficult to follow. Yet Maxwell persisted. He published his treatise on electricity and magnetism in 1873, a monumental work that would become the foundation of modern physics. Within its pages lay four equations, simple, symmetrical, and breathtaking, describing how electric and magnetic fields move and interact. These equations would later be known simply as Maxwell's equations. But their power was anything but simple. At their heart, Maxwell's equations told a story of connection. They said that a changing electric field produces a magnetic field, and vice versa. They said that these fields could propagate through space as waves, carrying energy and information. They said that light itself was an electromagnetic disturbance moving at a constant speed through the void. And they said, most profoundly, that nature operates not through isolated phenomena, but through continuous relationships. Nothing exists alone, everything is bound to everything else, by invisible threads of energy. The implications were staggering. Maxwell had shown that the very fabric of reality was filled with electromagnetic fields, even in empty space. What we call nothing is, in truth, a vast ocean of potential energy rippling with unseen motion. Light was no longer a separate mystery. It was the visible tip of a cosmic symphony, a harmony of electric and magnetic vibrations. Yet in his lifetime, Maxwell's genius was only partially recognized. His equations were admired by a few and misunderstood by many. It would take decades for the full impact of his work to unfold. After his death, experimentalists like Heinrich Hertz would confirm the existence of electromagnetic waves, proving Maxwell's predictions correct. From that discovery came the birth of radio, radar, television, and all the wireless communication that defines our modern world. But in the mid-19th century, Maxwell worked largely in the quiet of his own thoughts, guided by faith in the unity of nature. What made Maxwell remarkable was not only his intellect but his vision. He was not content to describe isolated facts, he sought patterns that revealed deeper truths. In this, he was both scientist and artist. He saw the universe as a grand tapestry woven of invisible forces, each interacting in harmony. Where others saw chaos, he saw design. His mathematical insight gave form to Faraday's intuition, transforming lines of force into the language of fields, a concept that remains central to physics today. Maxwell's mind worked like a bridge between worlds, between experiment and theory, between imagination and proof. He believed that mathematics could describe nature's music, that equations could sing. And in crafting his equations, he created one of the most beautiful symphonies of all time, one that continues to echo through science and technology alike. It is difficult, even now, to fully grasp the magnitude of his contribution. Before Maxwell, electricity and magnetism were curiosities, forces that could light a bulb or deflect a compass needle. After Maxwell, they became fundamental aspects of the universe, as real and omnipresent as gravity. He revealed that the universe is not a collection of disconnected objects, but a continuum of energy fields, each influencing the other across the vastness of space. To understand Maxwell's achievement, imagine standing at the edge of the known world and suddenly glimpsing the structure of the cosmos. His equations did not simply describe what scientists already knew. They predicted phenomena yet undiscovered. Radio waves, microwaves, X-rays, and gamma rays were all foretold by Maxwell's theory before any human had seen them. It was as though he had written a map of the invisible. Even Einstein, decades later, would call Maxwell's work the most profound and the most fruitful that physics has experienced since the time of Newton. Einstein's own theory of relativity, which transformed our understanding of space and time, was built upon Maxwell's foundation. The constant speed of light, the cornerstone of relativity, came directly from Maxwell's equations. Without him, the 20th century's revolutions in science would never have been possible. But in the 1800s, Maxwell's story was one of solitude, reflection, and perseverance. He spent long hours refining his ideas, often retreating into the quiet of the Scottish countryside, where nature's simplicity mirrored the elegance he sought in his equations. Those who knew him described a man of deep humility and kindness, uninterested in fame or recognition. His joy came not from applause but from understanding. To him, uncovering nature's laws was a form of worship, a way of glimpsing the divine order behind creation. As his theory took shape, Maxwell understood that he was standing at the threshold of something immense. He had connected three of the universe's greatest mysteries into one harmonious whole. But his health was fragile, and time was not on his side. Even as illness began to weaken him, he continued to write, to calculate, and to teach. He knew that his work would outlive him, that one day others would see what he saw, and indeed they did. The story of the man who sought to connect electricity, magnetism, and light is not just a story of science, it is a story of vision. The vision to see unity where others see division, to find harmony in the unseen, to believe that nature's complexity hides simplicity. Maxwell's journey reminds us that knowledge often begins in wonder, that the greatest discoveries arise not from power or ambition, but from curiosity and imagination. He was not driven by profit or fame, but by the quiet conviction that truth exists and that it can be found through reason and creativity. As we look back now, it seems almost inevitable that someone would uncover the unity of the electromagnetic world. But in truth, it took a mind both humble and bold, both logical and poetic, to see what others could not. Maxwell's life was the embodiment of that balance, the marriage of art and science, intuition and precision. His equations became the universal language of the invisible, a code that continues to shape every corner of modern civilization. When we flip a switch and light floods a room, when we send a message through the air, when we gaze at the stars and see their light traveling across space, we are touching the legacy of the man who connected the forces that once seemed apart. James Clerk Maxwell did more than unify the invisible. He illuminated it. He showed that the universe, in all its vastness, is one great interplay of energy and light. The story of Maxwell's quest is a reminder that the boundaries of knowledge are not fixed. They expand with every mind that dares to ask, what if these are not different at all? It is a story that begins in curiosity and ends in unity, one that transformed the way humanity sees the world, and perhaps the way the universe sees itself. The world of science was changing, and with it, humanity's way of seeing the invisible was about to be transformed forever. James Clerk Maxwell had already set his eyes on a goal that seemed almost unreachable: to prove that electricity, magnetism, and light were not different forces but aspects of one underlying reality. In the mid-19th century, the scientific community was filled with fragmented theories. Each field had its own boundaries, and few dared to imagine that these invisible forces might actually be one and the same. But Maxwell was not like other scientists of his time. He had a mind that could blend imagination with precision, mathematics with intuition. His work would soon become the bridge between the mysterious and the measurable, between unseen energy and the bright illumination of understanding. As he sat at his desk in Cambridge, surrounded by papers filled with symbols and sketches, Maxwell's thoughts traveled far beyond the confines of his study. He wasn't merely solving equations, he was tracing the heartbeat of nature itself. Electricity fascinated him, an unseen flow of energy that could make sparks jump and lights glow. Magnetism intrigued him, an invisible pull that could move metals and guide compasses toward the north. And light, the most ancient of mysteries, streamed endlessly from the sun, painting the world with color and warmth. Could all of these truly be different faces of one grand design? That was the question that haunted and inspired him. Before Maxwell, the world had known great scientists who uncovered pieces of this puzzle. Faraday had shown that electricity could create magnetism, and that magnetism could, in turn, produce electricity. But Faraday's work, though revolutionary, was expressed in lines of force, not in mathematical form. Maxwell admired Faraday deeply, yet he saw that what the world needed was a universal language, mathematics, to bring these concepts together into a complete theory. This realization became his mission: to translate the mysterious into the measurable, to write down the invisible dance of energy in the form of equations that would stand for eternity. He began to imagine the universe not as a void filled with isolated events, but as a sea of fields, electric and magnetic, that extended everywhere. He believed that these fields were the real fabric of nature, vibrating and interacting even in the emptiest space. Through countless nights of calculations and endless sheets of notes, Maxwell began to see the invisible lines forming patterns. He noticed that when an electric field changed, it created a magnetic field, and when the magnetic field changed, it generated an electric one. It was as though these two forces were chasing each other through space, an endless cycle of creation and transformation. This idea was both bold and poetic. It implied that energy could move through space even without matter, a revolutionary thought for its time. To the scientists of the 1800s, Empty space was truly empty, a nothingness through which forces could not travel. But Maxwell saw it differently. He imagined the vacuum as a medium filled with potential, where waves of energy could ripple like sound through air or waves through water. When he calculated the speed of these waves, he found something astonishing: they moved at the same speed as light. That number, 300,000 kilometers per second, matched perfectly. In that moment, Maxwell realized that light itself was an electromagnetic wave. It was as if the universe had revealed one of its deepest secrets to him. The sunlight that bathed the earth, the spark of a lightning bolt, and the pull of a magnet, they were all expressions of the same underlying energy. Nature was not divided but unified by invisible threads of electromagnetic force. The boundaries between electricity, magnetism, and light dissolved into a single, beautiful harmony. Maxwell's discovery didn't just rewrite textbooks. It reshaped human understanding. For centuries, philosophers and scientists had sought the key to the unity of nature, something that tied together all physical phenomena. Maxwell had found it. His equations, simple yet profound, were like musical notes that played the symphony of the universe. Each symbol represented a law of balance and motion that governed everything from the glow of a candle to the light of distant stars. However, his work wasn't immediately celebrated. Many of his contemporaries struggled to grasp its full meaning. Some even doubted his interpretation, arguing that light couldn't possibly be the same as electromagnetic force. Yet Maxwell stood firm, supported by the logic of his mathematics and the beauty of his vision. He wasn't merely making assumptions, he was describing reality at its most fundamental level. The power of his equations lay in their universality. They worked everywhere, from the smallest spark to the grandest beam of light. As time passed, the scientific world began to catch up. Experiments confirmed his predictions. The invisible became visible through the language of numbers and the precision of observation. Maxwell's unification marked the birth of modern physics. It provided the foundation upon which later giants like Einstein and Planck would build. Without Maxwell's equations, relativity and quantum mechanics might never have emerged in the same way. His vision of interconnected forces became a lens through which all of science would eventually view reality. Yet beyond the scientific triumph, there was something deeply human in Maxwell's achievement. His quest reflected the ancient yearning to find order in chaos, to uncover the hidden harmony behind the phenomena that shape our world. He turned mystery into meaning, proving that understanding the invisible doesn't diminish its wonder. It magnifies it. In the years that followed, Maxwell's name became a cornerstone of physics, but during his own lifetime, he remained a quiet figure, more fascinated by discovery than fame. He taught, wrote, and explored with an almost spiritual devotion to truth. He once said that the true goal of science was not merely to collect facts, but to uncover the unity that binds them together. And that is precisely what he did. From the flicker of a candle to the thunder of a storm, from the compass needle to the glow of a star, Maxwell revealed the common thread, a single force expressed in different forms, shaping the universe in silence. His unification of electricity, magnetism, and light was more than a scientific revelation, it was a philosophical awakening, a glimpse into the profound simplicity that lies beneath all complexity. As the modern world evolved, his equations found their way into every aspect of human life. The electric grids that power cities, the radio waves that carry voices across continents, the light that travels through fiber optics. All of these owe their existence to the principles he uncovered. The unification of the invisible forces didn't just change science, it changed civilization. Today, when we switch on a light, send a message, or watch the aurora dance across the sky, we are witnessing Maxwell's vision in action. His insight continues to echo through time, reminding us that the universe is not made of separate parts, but woven together by energy and law. The man who once sat quietly calculating in the glow of a lamp had, without realizing it, illuminated the path to the modern world. Maxwell's story is a testament to the power of the human mind to see beyond the visible, to imagine what lies beneath, and to express it in the language of truth. He did not just unify forces, he unified understanding. His work stands as a monument to curiosity, intellect, and the eternal search for harmony in the universe. Through him, humanity learned that light itself is a message from the invisible world, whispering of the unity that binds all things together. And so, the man who sought to connect the unseen became the one who revealed the universal thread of existence. His legacy lives on, not only in equations and experiments, but in every beam of light that shines, every magnetic field that moves, every electric current that flows, silent testimonies to the unity of the invisible forces of nature. In the quiet dawn of scientific discovery, there existed a mystery that had lingered for centuries. A mystery that humans could feel but not see. Lightning flashed across the sky. Magnets pulled on iron and amber, when rubbed, attracted small bits of straw. These forces, though invisible, shaped the world. People felt their power, yet their origins remained hidden. Before the age of modern science, such phenomena were often explained through myth or divine intervention. The crackle of electricity and the pull of magnetism were, to early civilizations, signs from the heavens. But as time passed, curiosity replaced superstition. The human desire to understand these invisible interactions grew stronger, setting the stage for one of the greatest transformations in human thought. Centuries before Maxwell or Faraday, ancient philosophers pondered these unseen forces. The Greeks had discovered that rubbing amber with fur produced a strange attraction to lightweight objects, and they called it electron. Around the same time, the power of magnets was observed in naturally magnetic stones called lodestones. These were early hints of the invisible forces that would one day be unified, yet for thousands of years, no one knew what connected them. To the human eye, they were mysteries without a thread. Each appeared to be an isolated wonder, fascinating yet separate. The Renaissance and the dawn of experimental science reignited the search for answers. Thinkers like William Gilbert in the 16th century studied magnetism with remarkable precision. He discovered that Earth itself behaved like a giant magnet, and that the compass needle aligned because of the planet's magnetic field. For the first time, magnetism was not seen as magic but as a measurable natural phenomenon. Electricity too began to attract attention. Scientists like Otto von Guericke, Stephen Gray, and Benjamin Franklin conducted experiments that revealed the strange behaviors of electric charge, sparks, shocks, and currents. Franklin's legendary kite experiment proved that lightning was not divine fire, but an immense discharge of electrical energy from the skies. Each discovery brought humanity closer to unveiling the hidden framework of the natural world. Yet, despite these breakthroughs, electricity and magnetism were still treated as distinct entities. Scientists of the 18th century could not yet see the bridge between them. The early experiments showed patterns. Wires that carried currents could produce magnetic effects, and magnets could move metal objects, but the underlying relationship remained veiled. It was Michael Faraday, in the 19th century, who began to pierce that veil. Faraday's genius lay not in complex mathematics but in imagination. He visualized lines of force, invisible threads connecting charged and magnetic objects, spreading through space like a web. Faraday's experiments revealed that electricity and magnetism were intertwined. When he moved a magnet through a coil of wire, a current appeared. And when an electric current flowed through a wire, it produced a magnetic field around it. This discovery was nothing short of revolutionary. It showed that one invisible force could give rise to another, a dance of energies that responded to each other's motion. But though Faraday's insight was profound, he could not express it in equations. His mind worked in images and intuition, leaving the task of mathematical explanation to someone else. That someone would be James Clerk Maxwell. When Maxwell encountered Faraday's work, he saw not just experiments but patterns, relationships waiting to be described in mathematical form. He realized that the forces Faraday had visualized could be expressed through precise laws that would describe how electric and magnetic fields move and change in space. Through his calculations, Maxwell found something astonishing: changing electric fields generate magnetic fields, and changing magnetic fields generate electric fields. These interlinked forces could sustain each other, traveling through space in the form of waves. This was the key. Maxwell's equations described the invisible interactions that govern the universe. But what made them truly extraordinary was that when he calculated the speed of these electromagnetic waves, the result matched the speed of light. The implication was breathtaking. Light itself was an electromagnetic wave, part of the same family as electricity and magnetism. In that moment, the invisible forces of nature were connected through a single unifying theory. The realization that light was electromagnetic changed the entire landscape of science. What had once been considered separate, the glow of the sun, the attraction of a magnet, and the flow of an electric current, were now unified under one law. Maxwell had uncovered the bridge between the physical and the invisible, showing that the cosmos was bound together by waves of energy rippling through space. This unification was more than a mathematical triumph. It was a philosophical revelation. The universe, once thought to be governed by separate laws and forces, was shown to be an interconnected web. Energy was no longer confined to the visible or tangible. It could move through the emptiest vacuum, carrying information and light across unimaginable distances. As experiments began to confirm Maxwell's predictions, the world's understanding of nature deepened. The invisible interactions that had once seemed random were now seen as part of a coherent system. Scientists discovered that the electromagnetic spectrum extended far beyond visible light. From radio waves to microwaves, from X-rays to gamma rays, all manifestations of the same fundamental principle. But long before technology caught up with theory, humanity's imagination was captivated. The invisible had become not only measurable but meaningful. Maxwell's equations revealed that the universe was not a void but a living sea of fields, pulsing with energy. The same forces that guided a compass needle also carried the warmth of sunlight across the heavens. Still, the story of these invisible interactions was far from over. As Maxwell's ideas spread, they inspired a new generation of physicists who sought to test and expand upon his theory. Heinrich Hertz, through his experiments in the late 19th century, generated and detected electromagnetic waves, proving Maxwell's predictions correct. These waves would soon give birth to radio, transforming communication forever. What had begun as a study of invisible forces evolved into the foundation of the modern world. Yet, behind every discovery lay a timeless truth: that the universe's most powerful forces are often the ones unseen. The electric current that flows through a wire, the magnetic field that shapes the motion of planets, the light that illuminates our world, all are threads in a cosmic fabric woven from invisible interactions. The early scientists, from Gilbert to Faraday to Maxwell, were not merely uncovering facts, they were unveiling the hidden architecture of existence. The journey to understand these interactions was also a journey to understand humanity's place in the cosmos. Each discovery revealed that the universe operates not through chaos, but through order and unity. The invisible forces are not distant phenomena, they are the very essence of life and motion. Every heartbeat, every lightning strike, every ray of light is an expression of the same laws that govern galaxies and stars. This realization reshaped human perception. The invisible world became not a source of fear but of wonder. What was once seen as divine or magical was now understood as natural, and even more awe-inspiring in its precision. The invisible interactions that shape existence remind us that truth often lies beyond sight, waiting to be revealed through the power of thought, observation, and imagination. As the 19th century came to a close, the invisible forces that once puzzled ancient minds had become the foundation of modern science. Electricity powered homes, magnetism guided navigation, and light connected humanity to the stars. The work of countless minds had transformed mystery into mastery, but the sense of wonder remained. The invisible interactions of the universe continue to shape everything we know, from the glow of a smartphone screen to the magnetic fields that protect Earth from cosmic radiation. They are the heartbeat of reality itself, uniting the smallest particles with the grandest galaxies. And at the center of it all lies the same enduring truth, that what we cannot see is often what holds everything together. The story of these invisible forces is, in truth, the story of human curiosity. It is the tale of our endless desire to see beyond the limits of vision, to uncover the secrets that lie hidden within nature's silence. It is a story that began with amber and magnets, grew through lightning and lines of force, and blossomed into a unified understanding of the cosmos. And it reminds us that even in the invisible, there is beauty, order, and the timeless rhythm of the universe itself. As the discoveries of the invisible forces deepened, the 19th century stood at a threshold between wonder and understanding. The world had begun to see that the unseen threads of nature were not random acts but part of an intricate, organized design. Yet, even with the breakthroughs of Faraday and Maxwell, the invisible still carried a sense of mystery, a feeling that there was something deeper waiting to be discovered beneath the waves of electricity, magnetism, and light. The scientific community of the time was alive with debate. Experiments had revealed that invisible forces could act across distances, and Maxwell's equations had mathematically unified them. But how could these forces travel through space? What was the medium that carried them? To many, the concept of empty space seemed impossible. Scientists imagined that space must be filled with a mysterious substance called the luminiferous ether, an invisible ocean through which electromagnetic waves rippled, carrying light and energy across the universe. For decades, this idea dominated scientific thought. In laboratories across Europe, experiments were designed to detect the ether. Physicists built delicate instruments to measure its effects, trying to sense the flow of this invisible medium as Earth moved through it. Yet, no matter how precise the experiments became, the ether remained elusive. It was a ghostly concept, unseen, undetectable, and perhaps unreal. The turning point came in the late 19th century, when Michelson and Morley conducted one of the most famous experiments in history. Their results showed that no ether could be detected. Light moved through space as if the medium simply didn't exist. This finding shook the scientific world. If there was no ether, then what carried the waves of electricity and magnetism? How could something move through nothing? The invisible forces of nature had once again challenged human understanding. But instead of breaking the theory, the mystery only deepened its beauty. Maxwell's equations still worked perfectly. They described how fields interacted and propagated, even if the space between them was truly empty. It was as if nature itself was whispering that reality is more subtle and mysterious than anyone had imagined. The invisible interactions that Maxwell described were not dependent on any substance. They were self-sustaining, existing within the fabric of space itself. This realization opened the door for a new way of thinking, one that would later inspire Albert Einstein. Einstein took Maxwell's ideas and saw that if light always moved at the same speed, then space and time themselves must adjust to preserve that constant. This revelation led to the theory of relativity, which further deepened the unification of natural forces. The invisible interactions of Maxwell's time became the foundation for a new vision of the universe, a cosmos where energy, space, and time were woven together in a seamless continuum. But the story of the invisible didn't end there. As the 20th century dawned, scientists began to probe even deeper into the structure of matter itself. The discovery of electrons, protons, and later subatomic particles showed that the invisible forces weren't limited to the vast scales of space, but also governed the tiniest building blocks of reality. The same electromagnetic forces that guided the light of stars also bound atoms together, holding the universe in balance. The invisible became not just a concept but a tangible reality, shaping everything from the glow of a candle to the structure of the cosmos. Throughout this unfolding journey, one thing remained constant: humanity's fascination with the unseen. Every discovery led to new questions, every answer revealed deeper mysteries. The invisible interactions that once inspired awe in the minds of early philosophers now formed the basis of modern civilization. Electric power illuminated cities, magnetic fields guided compasses and motors, and light carried messages through the air as radio waves. The same forces that had once been beyond comprehension now served humanity's greatest ambitions. And yet, for all our progress, the invisible continued to humble us. The more we discovered, the more we realized how much remained unknown. Even Maxwell's elegant equations, perfect as they were, could not explain everything. They revealed the unity of electricity, magnetism, and light, but not how these forces fit with gravity or the atomic forces that bind matter. The search for unification, for a single law that governs all forces, became the grand quest of modern physics. Still, Maxwell's unification marked the turning point. It taught scientists to look for patterns, to seek harmony beneath apparent diversity. His work showed that the invisible could be described, predicted, and understood through the power of reason and imagination. It was a triumph not only of science, but of the human spirit, a demonstration that the boundaries of perception could be expanded through thought and persistence. When we reflect on those early experiments, the rubbing of amber, the swinging of magnets, the faint sparks and trembling compasses, we see more than the beginnings of physics. We see the beginnings of understanding itself. Each invisible interaction told a story of connection, of forces that bind and guide without ever being seen. From the movement of electrons in a wire to the shimmering aurora in the night sky, these forces continue to remind us that the most powerful elements of existence often lie beyond sight. Today, satellites orbit the Earth using electromagnetic signals, radio waves transmit voices across oceans, and laser light carries information across continents through fiber optics. Every one of these technologies is a direct descendant of those first insights into the invisible. The same principles that guided Maxwell's equations now shape our daily lives, connecting humanity through an invisible network of energy and information. But perhaps the most remarkable part of this story is that it continues. Modern physicists now explore the quantum realm, where the invisible interactions grow even stranger. Particles flicker in and out of existence, and forces act across distances in ways that defy classical understanding. The electromagnetic force that Maxwell described is now seen as part of a broader tapestry that includes weak and strong nuclear forces, each a thread in the great weave of nature. The search for a theory of everything, a complete unification of all forces, still echoes Maxwell's dream of harmony in the invisible. In every way, the story of the invisible interactions that shape the universe is the story of human discovery itself. It shows how curiosity can transform mystery into knowledge, how imagination can turn the unseen into the understood. Each step, from the ancient study of amber to the equations of Maxwell, was a step toward illumination, both scientific and spiritual. And as we stand today, surrounded by invisible waves carrying voices, images, and data through the air, we live in a world built upon the very forces that once seemed beyond comprehension. Electricity powers our hearts and our homes, magnetism shapes our technology and our planet, light connects us across time and space. The invisible, once feared and misunderstood, has become the foundation of everything we know. The invisible interactions that shape existence continue to remind us of one timeless truth: that the universe is not silent or empty, but alive with connection. Each spark, each field, each wave is a whisper of the same cosmic symphony. From the first spark of human curiosity to the glowing screens of the modern age, we have always been listeners to that music, trying to understand its rhythm. Maxwell's legacy, and the legacy of all who sought to understand the invisible, is not just a scientific one. It is a reminder that knowledge begins in wonder, that even the most ordinary phenomena hide extraordinary truths. The invisible forces of nature are not beyond reach, they are woven into the very fabric of reality, waiting for those bold enough to look beyond the surface. And through them, humanity continues its timeless journey. From darkness to light, from mystery to meaning, from the unseen to the understood, it was a time of quiet revolution in the world of science, a period when imagination met mathematics and invisible truths began to take form. The world had known electricity and magnetism for centuries, yet no one could fully explain how they intertwined, how one invisible force could give birth to another. Experiments hinted at connections, sparks leaped between metal rods, compasses trembled before unseen fields, but the grand picture remained unfinished. And then, through the eyes of a mind that could see beyond the limits of ordinary perception, came a revelation that would change the destiny of science forever. James Clerk Maxwell, with his calm intellect and quiet brilliance, took upon himself the challenge that had puzzled even the most daring thinkers of his time. He was not simply searching for facts, he was chasing unity, a single truth that could bind the forces of nature together. While others worked in laboratories, Maxwell worked within the universe of mathematics, where symbols became the language of creation itself. His equations were not mere numbers on paper. They were the whisper of reality itself, written in the language of nature. The breakthrough came like light breaking through a storm. Maxwell discovered that when electricity moves, it generates a magnetic field, and when that magnetic field changes, it can create electricity again. The two forces were not separate entities fighting for dominance. They were partners, dancing in perfect rhythm, endlessly giving birth to one another. In this realization, Maxwell uncovered the heartbeat of the universe, a continuous interplay of electric and magnetic energy, shaping everything from the light that warms our planet to the signals that travel across the cosmos. He went further, daring to suggest that light itself was part of this dance. His equations predicted that electromagnetic waves travel through space at a speed almost identical to that of light. A clue so perfect it could not be coincidence. Light was no longer a mysterious, independent phenomenon, it was the visible part of a vast spectrum of invisible waves that filled the universe. For the first time, the boundaries between electricity, magnetism, and light dissolved. Nature's forces stood revealed as one. This breakthrough was more than a scientific discovery, it was a moment of profound beauty. Humanity had finally glimpsed the underlying harmony of the universe. What once appeared as chaos was now a symphony, guided by laws of elegant simplicity. Maxwell's insight didn't just explain how the world worked, it revealed that the universe itself was an intricate, living system of connected energy. His discovery showed that every flicker of light, every electromagnetic pulse, every unseen wave in the air was part of a single, magnificent story, the story of unity. Maxwell's revelation opened new doors for generations to come. His equations became the guiding light for physicists, engineers, and dreamers. They inspired the birth of radio, radar, and the vast web of communication that now binds the modern world. But beyond all inventions, his work gave humanity something deeper, a new way to see the universe. It showed that beneath the surface of every phenomenon lies a profound order, an invisible fabric connecting all that exists. And so, with the stroke of his pen, James Clerk Maxwell forever changed the way we see the cosmos. His breakthrough realization was not just the merging of forces, but the awakening of understanding. A timeless reminder that in the vastness of the unknown, everything is bound together by the same invisible pulse, echoing through space, through light, through life itself. From the depths of curiosity and the quiet brilliance of thought emerged one of the most elegant achievements in human history, the creation of mathematical laws that unified the forces of nature. James Clerk Maxwell did not build machines or conduct grand experiments, instead, he built bridges made of equations. His pen became a lens, allowing humanity to see the invisible architecture of the cosmos. In an era when science was still struggling to connect the mysterious behaviors of electricity, magnetism, and light, Maxwell dared to ask a question that seemed almost poetic: could all these forces be the language of a single truth? Through years of study, observation, and inspiration drawn from the work of Faraday, Ampere, and others, Maxwell began to assemble a system of equations that would describe how electric and magnetic fields behave. Each equation seemed simple at first glance, yet together they formed a symphony of logic and beauty. They were not random symbols. They were the pulse of the universe captured in mathematical form. These equations told the story of how a moving electric charge creates a magnetic field, and how a changing magnetic field gives rise to an electric one. This perfect balance was the foundation of all electromagnetic phenomena, the hidden rhythm guiding the forces of nature. For the first time, the unseen could be predicted, measured, and understood. The invisible threads of reality, electric currents, magnetic influences, beams of light, all began to obey the same set of mathematical laws. These laws were more than tools for scientists. They were a revelation about the nature of existence. Maxwell's mathematics did not just describe the world, they uncovered its unity. They proved that light, electricity, and magnetism were not separate entities, but different expressions of the same fundamental essence. Maxwell's equations were the culmination of centuries of wonder and exploration. They transformed mystery into knowledge, chaos into order. Where once the universe appeared as a collection of unrelated forces, it now revealed itself as a harmonious web of interconnections. Every spark of electricity, every flicker of light, every magnetic pull could now be traced back to these same equations. They became the heartbeat of physics, echoing across laboratories, classrooms, and eventually the stars themselves. The beauty of Maxwell's work lay not only in its precision but in its simplicity. 4 equations, elegant, balanced, and profound, could explain everything from the glow of the sun to the signals traveling invisibly through space. They marked a turning point in human understanding, showing that nature's greatest secrets could be expressed through reason, logic, and imagination. For the first time, humanity had written down the laws that governed invisible energy, bridging the gap between what could be seen and what could only be felt. These mathematical laws became the cornerstone of modern physics, laying the foundation for the revolutions that followed: relativity, quantum theory, and the technological era. Every modern device that uses electricity, from radios to satellites, from smartphones to power grids, owes its existence to the principles Maxwell revealed. His equations became the silent architects of progress, guiding humanity toward a deeper understanding of the natural world. Yet beyond science and invention, there was something profoundly philosophical in Maxwell's achievement. His work suggested that the universe itself was not random but purposeful, that there was harmony woven into its very design. In the elegant flow of his mathematics, one could almost hear the music of creation, a reminder that the invisible forces shaping our world are not chaotic, but beautifully connected. Through his mathematical laws, James Clerk Maxwell gave humanity more than a set of tools. He gave us vision, a way to see beyond the visible, to understand that everything we experience, from the warmth of sunlight to the magnetic pull of Earth itself, is part of a grand and unified order. His equations continue to whisper the same truth today, that the universe is not a collection of separate parts, but one magnificent whole, bound together by the invisible harmony of nature. The unification of nature's invisible forces did more than change the way scientists viewed the world. It transformed the entire course of human civilization. From the moment James Clerk Maxwell's equations revealed the unity between electricity, magnetism, and light, a new era of innovation began to unfold. The invisible became usable, the theoretical became practical. What was once a mystery locked within the equations of a Scottish physicist became the foundation for technologies that reshaped human life on every level. The transformation began quietly. At first, few understood the magnitude of Maxwell's work. His equations seemed abstract, the kind of mathematics that lived only in books. But as decades passed, Great minds began to realize what he had given them, a universal blueprint for understanding energy and motion. Scientists like Heinrich Hertz and Guglielmo Marconi brought those equations to life, turning waves of theory into waves of reality. When Hertz proved that electromagnetic waves could travel through space, and Marconi used those waves to send the first wireless messages, the world crossed into a new age, the age of communication. Electricity, once feared as a mysterious spark from the heavens, became the lifeblood of modern civilization. Cities began to glow in the night, powered by the invisible laws Maxwell had uncovered. Telegraph lines, radios, and later televisions carried voices and images across continents. What had once been bound by distance now flowed freely through the air, connecting humanity in ways no one could have imagined. The electromagnetic waves Maxwell described became the unseen bridges between people, ideas, and cultures. But the influence of his discovery went even deeper than invention. It changed the way humanity thought about the universe itself. Before Maxwell, light and energy were treated as separate from matter, different realms of existence. After him, scientists began to see that everything might be connected through underlying fields, patterns, and vibrations. This new understanding inspired Albert Einstein, who took Maxwell's equations as the foundation for his theory of relativity. Without Maxwell, Einstein might never have conceived of the relationship between energy, mass, and the speed of light, the formula that would forever change physics. The impact of Maxwell's unification spread through time, touching every branch of science and technology. From radio waves to microwaves, from X-rays to infrared radiation, each discovery built upon his foundation. The modern world of electronics, computers, satellites, and even the Internet can trace its lineage back to the mathematical vision of one man. His equations were not merely scientific tools, they were keys that unlocked the forces shaping reality itself. In every glowing screen, every wireless signal, and every light beam traveling through space, Maxwell's legacy continues to live. The unification of the forces of nature transformed not only the external world, but also humanity's inner perspective. It reminded us that understanding leads to power, but also to connection, to empathy, and to a deeper appreciation of the world around us. The same forces that move stars and planets also pulse within the circuits of our devices and the neurons of our brains. The progress that followed Maxwell's discovery became a mirror of his belief that knowledge should illuminate, not divide. The technological revolution his work inspired gave rise to global communication, scientific exploration, and even the dream of understanding the origins of the universe. It bridged gaps between nations and disciplines, proving that the invisible can unite what the visible divides. Today, as we look at satellites orbiting Earth, transmitting data across oceans and through space, we are witnessing the living proof of Maxwell's vision. His unification of the forces of nature transformed more than science, it transformed humanity itself. It gave us the power to harness energy, to communicate across worlds, to explore the cosmos, and to imagine futures once thought impossible. The invisible forces he revealed continue to shape every heartbeat of modern life, a silent yet powerful reminder that from unity comes understanding, and from understanding comes the light that drives civilization forward. In the quiet legacy of James Clerk Maxwell lies a story not just of equations and discoveries, but a vision that forever changed humanity's understanding of the universe. His unification of electricity, magnetism, and light was more than a scientific triumph. It was a moment of profound revelation, when the invisible structure of reality was finally seen for what it truly was, a single, harmonious fabric connecting all things. Maxwell's legacy is not bound by the 19th century, it stretches across time, reaching into the heart of modern science and the soul of human curiosity. Before Maxwell, the universe was a mystery divided. After him, it became a masterpiece of unity. His work became the cornerstone upon which modern physics was built. Albert Einstein would later say that his own achievements stood upon Maxwell's shoulders. Without the unification Maxwell revealed, there would be no theory of relativity, no understanding of space-time, and no path to quantum mechanics. His equations became the silent architects of the scientific revolutions that followed. In every discovery of the modern age, from the bending of light by gravity to the transmission of information through invisible waves, Maxwell's influence continues to guide humanity's quest for truth. But Maxwell's legacy goes beyond laboratories and formulas. It exists in every aspect of the modern world, in every light bulb that brightens a home, every radio signal that crosses oceans, every image that travels through space. The technologies that define our civilization, electricity, communication, digital networks, all trace their roots back to his unified vision. His work became the foundation upon which humanity built its connection to the cosmos and to itself. Through the invisible dance of electromagnetic waves, we found a way to bridge distances, share ideas, and illuminate the unknown. There was also a poetic depth to Maxwell's understanding, a sense that his discoveries were not only about science, but about beauty. He believed that nature's laws were expressions of harmony, that mathematics was not a cold instrument, but a reflection of the universe's inner order. In the symmetry of his equations, he saw art. In the unity of forces, he saw truth. His work showed that the universe was not random chaos, but an elegant composition written in the language of light and energy. That vision continues to inspire scientists, philosophers, and dreamers, reminding them that understanding the cosmos is, in essence, an act of wonder. Through Maxwell's legacy, humanity learned that knowledge is not an end, but a beginning. His discoveries opened doors to new realms of possibility: the study of electromagnetic radiation, the exploration of atomic and subatomic worlds, the communication systems that now link every corner of the globe. Each advancement carries a fragment of his insight, echoing the same truth: that all forces, all matter, and all energy are connected by invisible laws that weave through the heart of existence. Yet perhaps the greatest part of Maxwell's legacy lies not in what he discovered, but in what he taught humanity to believe: that beneath every mystery lies unity, and beneath every equation lies meaning. He showed that science and imagination are not opposites, but partners in revealing the beauty of creation. His equations became a universal language, one that transcended nations, cultures, and time itself, speaking to the eternal human desire to understand the world we live in. As the modern age continues to evolve, as we send probes beyond the solar system, decode the signals of distant galaxies, and explore the boundaries of space and time, Maxwell's legacy remains our compass. Every beam of light we study, every wave we harness, every field we measure is a continuation of his dream. His unification of the invisible forces did not simply explain how the universe works, it revealed why it holds together through balance, harmony, and connection. And so, the story of James Clerk Maxwell is not one that ends with his life. It continues in every scientific breakthrough, in every spark of innovation, in every human effort to see beyond the visible. His legacy is eternal, the realization that the universe, in all its vastness and mystery, speaks one language of unity. In the silent hum of electromagnetic energy that surrounds us, Maxwell's voice still echoes, a reminder that everything from the smallest atom to the farthest star is part of one magnificent, invisible whole.